Hello friends, welcome back to my YouTube channel MS Maths. In this video, I will discuss the ordinary differential equation for GATE engineering mathematics. So basically, we are going to discuss one short video. This one is the one short video, and in this we'll discuss ordinary differential equation, which is asked in the GATE engineering mathematics. So in this video, I'll discuss complete concept of the GATE engineering mathematics, and you can get also the previous year question for all the branches from last 15 to 20 years basically. So now let's start with the concept of ordinary differential equation, and then we'll go for partial differential equation with some another video. So basically, what is the differential equation? So the definition of differential equation is something. Differential equation is defined as an equation containing the derivative of various orders and variables. So basically, first of all, I just wanted to explain that when we will have a function that is y is equals to some function of x, if we will differentiate this function, then we'll write it as y dash. It means it is nothing but dy by dt, or dy by dx, and this one will be the differentiation of this function, will be representing as the f dash of x. So equation is nothing but which will be equivalent. There is a left hand side and right hand side, and if equation involving the derivative part. So what is this? This is nothing but the derivative parts. So equation involving the derivative part of the various order. It means if I will differentiate one time, then it will be first order derivative. If I will differentiate again, it will be second order derivative. So these kind of various the derivative will be there. So this equation is called the differential equation. So this one is nothing but the simple differential equation model is there. And in engineering problem, obviously you will have so many kind of model where the physical model is basically the modeling and representing with the differential equations. For example, a spring model, even we can say the acceleration and velocity model for any kind of object, that is nothing but the differential equation, which is kind of ordinary differential equation. Okay, so in this case, what is the order of differential equation? I say my function y is equals to f of x, or something y is equals to f of t. Function is function of time. So if I will differentiate first derivative of this, I will differentiate one time, then it will be y dash and it will be y dash of t. Okay, so it is basically the order. Order is nothing but the highest order derivative occurring in the differential equation. So this is nothing but a first order differential equation. It means it has the derivative of order 1. Okay, next if I'm going to writing the differential equation like this, d2 y by dx square plus dy by dx plus 5, okay, y is equals to some x square. So what's the order of this differential equation? It is the second order. It means the highest order derivative present in that differential equation. So the order of this differential equation is second. Now the degree, this is the main important concept, is that the degree is nothing but the highest order derivative, and whose power is basically called as degree. It means what is the power of this highest order derivative? That is nothing but 1. So this is nothing but the degree for this is 1 and the order for this is 2. This is called second order linear differential equation. Okay, it means the linearity is related to something degree. Okay, so this is the very simplest form we are taking here, but the main thing is that highest order, or basically the power of highest order derivative occurring after equation has been made rational and integral in the all of its derivative. It means in the simplest form of the differential equation, what is the highest power of the differential equation is called the degree. I'm taking an example here, that is the note point. One thing is there, you should have an idea about this. If it is a differential equation, because of that it is containing the derivative portion, and it must be a differential equation. Of course, it is a differential equation. Now, one concept is that differential equation, if I'm writing a differential equation, is that dy by dx is some function of x, then in this case, what is the scenario is going on? The solution of differential equation is nothing but y is equals to some kind of function of f of x, or I'm just writing it is nothing but some g of x. So here my y is depending on x. Whether the x will be changed, then the value of y will be also the change. So in that case, my y is called dependent variable. So I'm not like taking any kind of value of the y. I will just replace x in this function. I will get any kind of y related to that axis, related to that value of x. It means it is a dependent function, a dependent variable. Whether the x is called independent, independent kind of variable. So in this case of like y will be the dependent and x will be the independent variable. So if the derivative of independent, or sorry, if the derivative of dependent variable like dy by dx is occurring in any kind of non-linear or any kind of function, if cos, if I'm asking like talking about the cos, what is this? This is a non-linear function. It means it is a function. It is a graph like this. So any kind of the derivative of the basically the the like dependent variable is occurring in that, so it is kind of non-linear kind of differential equation. But it is not the simplicity form. We can't integrate this, like, because if we will have a cos of dy by dx, so I can't perform the derivative over this function, so it is not the rational integral form. So we can't find the the degree of this function. So here the degree cannot be determined. Because of that, the differential equation cannot be written in the like in the simplest form, or we can say that the rational integral form. Okay, this is the main concept here. That one is the note for you. So next one is basically the formation and solution of differential equation. Is basically that what is the solution of a differential equation. First let me discuss about that, the differential equation solution. Okay, so whenever we will have a differential equation, it is a kind of we will say that the general form of differential equation is nothing but a0 of yn, which is representing the derivative of like another derivative of this plus a1, that is n minus 1, and up to we can say that a n, and this will be the a n minus 1 will be the y, plus a n is equals to some function of x in the right hand side. Now this is the general form whenever my a naught is not equals to 0. So in this case, this is representing a differential equation, or basically the equation of a derivative, in which the solution of differential equation is nothing but a family of curve. So what do you mean by family of curve? The general solution, we are like, while we are discussing about the general solution of differential equation, it is representing it may contain, or it will contain basically the arbitrary constants are there. For example, like my solution will be the function of x and some constant c will be there. Okay, now what is this? This is nothing but a function. Function of what? Function of x and c, where x is that independent variables, independent variable, and c is what? That is basically the arbitrary. My c is here. C is called arbitrary constant. So it means that there will be arbitrary constant. There may 1, 2, 3 or whatever. Now the question arises that how many constants in the solution arise in the how many constants arise in the solution or in the general kind of solution. Okay, this is the general solution of any kind of differential equation. If we will replace that constant, or if we will find, or we are able to find the solution of constant, then it will be a particular solution. It will be either depend on the initial value problem and boundary value problem that we'll discuss later. So the number of that arbitrary constant is depending on the order of that differential equation. What is the order of differential equation? Is representing the number of constants. So it means the number of arbitrary constant is equals to the order of differential equation. If I have a second order differential equation, it will contain the two arbitrary constants in that. Okay, so the general solution will contain the the arbitrary constant, as well as the obviously it is a function of independent variable, and it will be a family of curve. Like whether I will change the value of c, it will be a like any kind of function. Okay, just say it is my line. Equation of line is that y is equals to mx plus c, or basically I can write it as y is equals to x plus c. It is nothing but a solution of a differential equation, and it is the general solution. Whether my c is equals to 1, then x plus y, it is representing a line. If it is x plus 2, it is representing the another line. So this is the general solution. Okay, so these are the solution of only one differential equation. The associate differential equation is only one, but the condition is changing according to c, or basically c will be changes according to the condition. Okay, So like this is the case. These are the particular solution and this is the general solution. Okay. Now we have example that y is equals to a cos of 2x plus b sine of 2x. It means we have two arbitrary constants here. So what is the order of differential equation associated for this this kind of solution or this kind of family of curve? It will be the second order differential equation. So basically, this is the solution of this is the solution of second order differential equation. Okay, so this is the all about the formation and the solution of differential equation. You can't form any kind of differential equation using its solution. It means it is a reverse process. We can find the solution of differential equation, and using the solution of differential equation we can find the differential equation also. So if you will differentiate two times this solution, you will get the second order differential equation, while the concept is that you will have to remove, or you will have to find the value in terms of arbitrary constants. So basically arbitrary constants will not be there. It should be replaced with the value of y. Okay. Next, so the type of differential equation are basically two types of differential equations are there, or basically in the case of ordinary differential equation, we'll have two types of differential equation. That is basically the linear differential equation and non-linear kind of differential equation. In partial differential equation, there are also linear and non-linear. So what is the meaning of linearity and non-linearity in this case? So the meaning is that it is completely related to the degree. Okay, so whether the degree is one of the differential equation, it will be a linear differential equation in the 90% of the case. Now, what is the case of the linear differential equation? Is it representing a differential equation of the form? So what is the meaning of this fd is equals to f of xy? It means that it is representing the derivative, whether it will be a first order, second order, or whether it is be like higher order kind of derivative will be there. So in that case, no power like y square and dy by dx square. It means you are getting that. What is this? This is basically your y is equals to dependent variable. So no power or no higher power must be occur in that differential equation of independent variable. It means y is enough. If y square is there, then it is not linear. Okay, like this will be the non-linear case, and also the derivative portion and the power of derivative also should not be 2 in this case. And simply the multiplication of any dependent variable to its derivative. So for example, if y dy by dx is occurring in any kind of differential equation, it will not be a linear kind of differential equation. And the solution for this differential equation is that sum of solution is also a solution. It means the solution for the case is basically the linear combination, that is the c1 y1 plus c2 y2 and like c3y3. So we can represent it as like that, the summation of the arbitrary constant ci yi, whether I is belonging from 1 to n. Okay, so here are some examples like dy by dx is equals to dy plus e to the power x. Here e to the power x is a linear, is a non-linear kind of function. Okay, but it is in the independent variable, not in dependent variable. If here is e to the power y is there, then we can't say that it is a linear. Okay, now it is a linear differential equation. Second one is the like y double dash minus y dash, y double dash plus y dash is equals to 2y minus sine x. It is also a linear kind of differential equation. These kind of things are not appear in this equation. And on the other hand, we can say that non-linear differential equation is something opposite to this kind of differential equation, which is basically the if y square and these kind of terms are there appearing in the differential equation, which is the non-linear kind of differential equation. And similarly, if multiplication also depending variable is in multiplication with the derivative of that dependent variable, then also it is a the non-linear kind of differential equation. And obviously, if non-linear functions are non-linear functions of y is nothing but the dependent variable. If any kind of function or any non-linear function is presenting in that equation, then it is not be a non-linear differential equation. Like sine of y, it is non-linear function. E to the power of y, y square is also there. This is the parabolic function is there. So these kind of functions should not be in the differential equation. If it is present, then it is a non-linear kind of differential equation. Now, the method of solving like first order differential equation. So first order differential equation is something whose order is 1. So in that case, we are discussing four like different kind of techniques to solve in the engineering problem or in the gate. Like these are the important topics like from where the question is like arising. Okay, so basically variable, first one is the variable separation. The concept is that it is what, it is the first order linear kind of differential equation. But you can see in this case of differential equation, these are the separate function of x and separate function of y. Okay, for example, I'm taking the dy by dx is equals to 2x and y. I can take it as a function of x and it as a function of y. If it is a function of x plus y, if it is a kind of like this x plus y, then I can't separate it, because it is in the like it is not in multiplication, it is in plus sign is there. Okay, this case we can't separate this basically because it is in multiplication. Separate means like that if you are going to integrate, then like same kind of variable should be in the same integrand. Okay, like if I'm going to this kind of differential equation, then I can easily separate this dy over y, and it is nothing but x of dx. Then I can find the solution. So this will be the solution in this case. Okay, but the like one arbitrary constant will be there. Because of that, the degree of this, or the basically the order of this degree is 1. It means a linear kind of differential equation, and non-linear also can be solved using this. If it is a y square, then we can easily solve this. Okay, no problem there. Like it is for linear and non-linear, it can solve both the kind of differential equations. But the thing is that the order should be 1. So in that case, order is 1, and we can, like, this will be the solution. This is called the variable separation method, and we are separating the variable in this case. Now going to next. Okay, the next one is a homogeneous kind of differential equation. It is also a differential equation in which you can solve linear and non-linear kind of differential equation. But the thing is that you can write, or you are going to be able to find any kind of function or in the form of this y by x. So for example, I'm taking dy by dx is something x square plus y square, or something x plus y. We can take x plus y upon x minus y. So this is what if I will replace my y is equals to v of x, then it will be it will remain same. It means if I'm going to write like this, so it will be x plus vx upon what it will be, then it will be x minus of vx. Then I can write it as 1 plus v and 1 minus of v. So like this is basically it will convert it to only a one one variable will be there. So you can easily find the solution. We'll see the example in the previous year question solution. You can visit the playlist of the GATE previous year solution. Okay, so in this case, if you will replace this, then if you are going to replace that y is equals to v of x, then you can replace dy by dx is nothing but v plus, okay, v, and you are going to apply u into v differentiation formula here. Then v, first differentiate this and second differentiate this. So first, if you are going to differentiate v, then it will be, okay, if you are going to differentiate x, okay, first if you are going to differentiate x, first this one and second this one, then it will be x, the differentiation of x will be 1, and second one is the x, and this will be the dv by dx. So we are going to replace this derivative with this, and you can find, and you can solve using, and you will land up to the variable separation method, obviously. Okay, and after that you will integrate and you can get the solution. Next one is the linear differential equation. This is the one of the specific and one of the important, from where the so too many questions are there in the GATE engineering mathematics. So in this case, basically these kind of linear differential equation, in which this is called the first degree, or basically first order linear differential equation. This is the particular kind of differential equation. If you have a differential equation of the shape of like this, dy by dx plus p of x, y, and q of x, y. Now in this case, p and q, my continuous function on that particular interval on which you are going to calculate the solution, then the solution will be exist. So in this case, you are going to first find the integrating factor. So integrating factor is nothing but e to the power of integration of this coefficient of y, it is p of x, and the solution of this is basically the y into the integrating factor. It means y into e to the power of p of x dx, and next one will be the integration of q of x, which will the right hand side, and the integrating factor, that is the integration of p of x dx plus c. Obviously it is a first order differential equation, then only one arbitrary constant will be there. Next one is a Bernoulli differential equation. This is a non-linear differential equation, but you can convert this differential equation to linear differential equation and you can apply the same method. But how will you convert this? So the thing is that here we can easily move to this. So just let me explain how can you move to this. So if this is the differential equation here, then I can write it as 1 upon y power n dy by dx plus p of x upon y power n, y is equals to q of x. Now see, this is the kind of differential equation, but the coefficient must be 1 for this case. But here it is, the coefficient is not there. And one thing that I just told you, that if the derivative, if the independent variable is the multiply of the derivative or its derivative, then it is a non-linear kind of differential equation. Then it is a non-linear differential equation, of course. So in this case, what we'll do, so we'll just assume this part. So this 1 upon yn will just consider as some z or some t. Now in this case, we are going to replace this thing. What we'll do, we are just writing here, or we can just write here. Basically, okay, yeah, one thing is that not considering this, just consider this as something. Okay, so y upon y power n is something z, or it is nothing but y. 1 minus n is something z. And now if you are going to differentiate this thing, this will be 1 minus n. Okay, and then it will be y, and it will be 1 minus n minus 1. Okay, and after that you can write it as dz by dx is here, and obviously dy by dx is also here. So it will be 1 minus n, okay, 1 upon y power n dy by dx is equals to dz by dx. Now you can replace this thing, this thing with this kind of linear differential equation. Or your non-linear differential equation will be converted to a linear differential equation, and you can find the solution. This may be the generalized solution, or even you can use this one. And after that, after substituting all these values, so your differential equation will be in z. So here it will be z is equals to something. Okay, and after completing the solution, you can just replace it out. Z is equals to y power 1 minus n. So we'll do the question in the a previous year series, so don't worry about it. Next one is the exact differential equation. This one is also one of the important and one of the easiest method, and one of the frequently asked topic in the GATE engineering mathematics, in the basically mechanical and civil engineering branches. So here we'll have differential equation kind of like this. This will be probably the function of x and y, and dx plus n, and the function of x and y dy is equals to 0. In this case, the differential equation is called exact differential equation if the partial derivative of this m with respect to y and this n with respect to x is equals to. So if these both are equal, then we'll call it as a exact differential equation. And the solution in that case is basically that okay, what is the partial differential equation? Is that partial differential equation is partial derivative is basically that in this case, if you are differentiating with respect to y, then x will be the constant here. Okay, while differentiating with one variable, then another will be the variable will be the constant, as treated as a constant. Okay, now the solution in this case is basically m of dx, but here you are integrating with respect to x, so it means all of your y is basically the constant. And another one is second one is you are differentiating integrating with respect to y. It means that you are going to taking n, but which n we are going to take? In that n in which there is no x term. For example, if my n is equals to x square plus y square plus x into y, now I will take only y square from out of this n, completely this n. I will neglect these both, because this is my x. Okay, this is my x. I will not take, this is containing x, so I will just write here y square, and this will be the same. So this is the solution of this differential equation. Okay, so this is called the exact differential equation here. Okay, now let's move to the higher order kind of differential equation. These all are first order differential equation, and the method to solve first order differential equation are there. Okay, now we'll have higher order differential equation in which we'll have the constant coefficient and variable coefficient. Later we'll discuss. So first, the higher order means that it may be second order, third order, fourth order with the constant coefficient. Now here a1, a2, a3, these all are constants, and somewhat we are like we are representing with the derivative d. So capital D means d by of dx. It will be the operator. It is called differential operator. Okay, and d2 means d2 by dx square, means the second time derivative, and the third time derivative is representing as d3, where a1, a2, an all are the constants, and this will be the function of x. Now the solution of this differential equation will be given in the two part. First one is the complementary function. This is basically the complementary function, and the second one will be the particular integral. So the complementary function and particular integral will be there. So what is the rule to calculate this? So these are the rule, very basic. Whenever we will have this kind of differential equation, first of all, just let me take an example. If you have, if you have the differential equation, for example, let's say second order differential equation, y double dash plus y is equals to some function of x. Now the y of c is nothing but the complementary function and also known as the solution of homogeneous part. Homogeneous part means that if you are taking only the left hand side, that is nothing but this, which is equals to 0. So the solution of this part is only called as homogeneous part or complementary function. If it is 0, then the solution is only the complementary function. Okay. Now you are going to find the auxiliary equation. Auxiliary equation means that the second order derivative will be replaced as m square, first order replaced as m power 1, and this will be the 1 is equals to 0. Now it is what the quadratic equation, and you are going to find the root of quadratic equation. On the basis of the characteristic of that roots, you are finding the solution. So basically, first one is that cases arise that if the roots are real and distinct, for example 1 and 2. Now the solution is what? C of 1 e to the power of 1x plus c2 e to the power of 2x. If it is 3 is here, then c3 e to the power of 3 is 3 of x is here. It is for what? The distinct and real root. Okay, so this is the solution. Next one is the real and repeated root. For example, it may be like this. It may be like this. My m minus 1 whole square is equals to 0. Then my m is equals to 1 here. Okay, 1, 1. So it will be kind of c1 plus c2 into x. If it is repeating 2 times, then it will be c1 plus c2 into x e to the power of 1x. Okay. If it is 3 times repeating, so it means it will be c1 plus c2x plus c3x square e to the power of 1x. Okay. Now, along with the repeating root, one root is my different. For example, 1, 1 and 2. So it will be 2 roots are repeating, then c1 plus c2 into x e to the power of 1x plus for this 2, it will be c3 into e to the power of 2x. So this will be my complementary function for this case. If complex roots are there, or basically the complex roots are obviously in the conjugate pair, it means it will be in the alpha plus minus iota beta, then it will be represented like as e to the power of alpha x, and next one is the c1 cos of beta x plus c2 sine of beta x. This one is the solution in the case of complementary, basically the complex function, complex roots are there. If the complex roots are also repeating in that case, so you are just going to write the same case, c1x plus c2 in the cos of beta, and next one is the c3x plus c4, because it is repeating in the same with the pair, because the complex root occur only in the pair. So these are the concept. Another one is the particular integral. So if your differential equation is a kind of like this and your f of x is not equals to 0, then you have to calculate the particular integral also. So what is the particular integral in this case? So particular integral arises basically when the non-homogeneous part is also there, which means the right hand side is not 0. So what we'll do in this case, basically we are just finding that we'll just replace this one is called my homogeneous part, and we'll just replace this as d square plus d plus 1 into y. And what is my y? Y is nothing but my f of x divided by this function. This is nothing but f of d. Okay, now whether f of x e to the power of x, sine hyperbole of x, or some polynomial may be there, or some combination of functions are there, then these are the rule. What will you do? If it is e power of x and this function, and if you are putting d is equals to a, which is nothing but the coefficient of x, which is the power of e. So if you are putting it is not equals to 0, then it is the particular integral. If you are putting and it is going to be 0, so in that case you have to differentiate, or basically you will have to differentiate this one. Okay, you will perform the differentiation for this, and you are going to multiply x on numerator. Okay, denominator you are differentiating, and in numerator you are just multiplying x. Again you will put the value of x. If it is not working, you are doing the same process until if it is not satisfying. Next one is the sine and cos of x. If it is there, sine b of x and cos b of x are there, then you are just replacing the d square with minus of b square. Okay, not minus b whole square, it is minus of b square. Okay, if it is not d square is presenting in that, so in that case you will have to multiply, if it is like this 1 by d, then you are going to multiply and divide with the d, then it will be d upon d square. This d means the derivative. You are going to differentiate the numerator side, and here it will be d square, and you are going to replace with d square, d square with minus of b square. Okay, and if your sine hyperbolic function is there, then you are just replacing with the d square and with just b square, just positive of b square, not negative of b square. Okay, the same thing is here, and then the same thing is for x bar m. For x bar m, you have to find the binomial expansion. These are the important, the expansion for there, that 1 plus d power minus 1 is 1 minus d plus d square minus d cube. Okay, and these d's are basically the the derivative case. Okay, so these are the case if your combination is occurring with e to the power, for example e to the power ax into some sine of x. So in this case what will happen? So it is your function of d. Now you are going to replace your d with d minus a. Okay, if it is a single e power x, then we are just replacing d with a. But it is a combination of function, and some function of x is arising with this e, then you are just replacing d with d minus a. And after that you are applying this sine rule, cos rule, whatever it may be. Okay, next we'll have example. We'll take the one simple example. For example, this is my differential equation, and what is the auxiliary equation for this? It is nothing but m square plus 4 is equals to 0. Then what is this? The root r 2 plus minus 2 iota. It means it is 0 plus minus 2 iota. So for alpha plus minus beta iota, it is nothing but e to the power alpha x c1 e to the power of c1 e to the c1 cos of beta x plus c2 sine of beta x are there. But here alpha is 0, it means it will be 1. So I can just write c1 cos of 2 is nothing but beta, and c2 sine of 2x. Now here the particular integral is nothing but e to the power of x and dividing this one. So I have e to the power of x upon d square plus 4. So what is the coefficient? It is 1. So I will just put here. So it will be e to the power of x, and it will be 1 plus 4. So 1 square plus 4, it will be e to the power x upon 5. Okay, one thing is that particular integral, there is no constant in particular integral. So if it is a second order differential equation, then two constants are arising in the complementary function only. So all the arbitrary constant will arise only in the complementary function, not in the particular integral. So this will be the complete solution. It means it is a what? Y of c, and it is what? Y of p. Particular integral and complementary function. This will be the complete integral for this case. Next one is the Cauchy-Euler equation. This is a kind of variable coefficient, where we will have x power n minus 1. Okay, so in this case, it is a very particular case. If you will have this kind of differential equation, or the shape of differential equation is this, called the Euler Cauchy differential equation. In this case, you are just replacing x with e to the power z. It means you are just replacing x square d square with d dash minus 1. Now what is d dash? So what is your d? D is nothing but d by dx is the derivative with respect to x. If you are assuming your x is function of z, it means z is equals to something log of x. It means the d dash is nothing but d by of dz. So you are complete differential equation will be converted from Cauchy-Euler equation to constant coefficient linear ordinary differential equation. And after that, you can apply the same process of the constant coefficient, the complete like the complementary function and the the particular integral. But keep in your mind, you are just replacing your differential equation will be in the z. After that you will have to replace z is equals to log of x. Everything will be converted and everything will be substituted. Otherwise, your answer will not be correct. Okay, so these are all about the solution and the basic concept of differential equation. And one thing is that somewhat the question arises related to IVP and the BVP, and it means that initial value problem and the boundary value problem. So what is this? If you will have a differential equation, or basically if I have a differential equation, for example, f of d into y, and it is basically the function of x, then the solution of differential equation is nothing but y is equals to function of x and c. So where c is the arbitrary constant. So if it is an arbitrary constant, it means that it is like based on the order of differential equation. If I will have a differential equation y double dash plus 4 is equals to, or for example, yes, okay, y double dash plus 4 is equals to 0, then what is this? This is nothing but the auxiliary equation is nothing but m square plus 4 is equals to 0, then m is equals to plus minus 2 iota, and it will be c1 cos of 2x plus c2 sine of 2x. It is the solution. Now the thing is that how can we find? This is nothing but the general solution. This is basically the general solution. How can we find the solution? How can we find the basically the the concept? It is called the initial value problem. If it is one point, it is defined on a point a of b. It is called initial value and if it is a of b and the second one is the some c of d, it is called boundary value problem. Using this, we can find the solution. So this is all about the differential equation. I hope you are getting the concept. So thanks for watching my video. Keep watching MS Maths. Thank you. Bye bye.